Now you know how temperature is related with the heat, and then the third one is a specific heat capacity. A very warm welcome to this lecture of climatology. Here we will discuss the heat and how heat drives the various climatic phenomena. For example, tropical cyclone. You know that latent heat of condensation is the fuel for tropical cyclone, but that is an advanced topic. Before reaching there, we have to elaborate what is the relation between different form of heat and how it is related with the temperature. So let's start from the beginning. So when I say heat and temperature, here we have 1 minute. Yeah. Heat and temperature, are they same? They may appear to be describing about a similar authority or similar property, but I will say they are different. How so? Heat is what? It is the kinetic energy of a molecules in a substance. Okay. When I say temperature, it is the measure of average kinetic energy of a substance. So in one case, it is the intrinsic property of that body because it is itself a form of kinetic energy, the heat, and temperature is the measure of that average kinetic energy of a substance. Okay. So first thing first, many a time you may see if there will be increase in heat, it may lead to increase in temperature. That is the general trend which we are aware of. But many a times you will notice that even if you are supplying the heat, there is no change in temperature. This gives rise to the concept of latent heat. Okay. So before going to latent heat, we will see further differences between the heat and temperature. So when I say heat, since it is a form of energy, it is measured in form of joule. So joule is SI unit of heat also. For temperature, it is your Kelvin. And beside Kelvin, you have degree centigrade as well as degree Fahrenheit. For heat, another unit you are aware of is calories. That calories is gained from the food we eat. And why it is named as such? Because the food we eat is utilized for growth, but the major portion of the food we eat is utilized for the energy metabolism. Means jitna aap khana khate ho, the majority of them are utilized in form of heat loss. Okay. So that's why this second term is also related to the heat. First one is your joule, second one is your calorie. These are unit of heat. For temperature, we have Kelvin, we have degree centigrade and degree Fahrenheit. Although आपको पता है, but I will just give you a clue. If I have 100 degrees C of water, that is the boiling point of pure water, in Kelvin it will be 373 Kelvin, and in Fahrenheit it will be 212 degrees Fahrenheit. So these are the units of temperature. Now when I say what is the nature of heat and what is the nature of temperature, so nature of heat is that it is a form of energy which may transfer from one body to another, probably or not probably, almost every time it is from a higher heat capacity to the lower heat capacity. Even in case of temperature, it also shows the direction of that transfer. Again, if you have a higher heat body or higher temperature body, the transfer of heat energy will always take place from the higher temperature to lower temperature. Then on one case, heat and temperature, the factor on which the heat is dependent of are, when I say heat, it is dependent on the mass of body. Okay. Then along with mass of body, it is also dependent on the temperature of body. Now you know how temperature is related with the heat, and then the third one is a specific heat capacity. Just rewind this lecture back in 5 minutes. So when I told you in the beginning, heat is what? It is the kinetic energy possessed by the molecule of a substance. Okay. So if a molecule, if it is more massive, definitely it will have more mass also. So if a body having higher mass, it will have naturally having higher heat energy. But that does not guarantee you a higher temperature. So the first factor, mass of body, means it has a positive correlation with heat energy, because I told you higher the mass, higher will be heat energy. When I say temperature, so it is the, what was it? It was the average kinetic energy of the substance. Okay. So in this case, if a body has higher temperature, means it has relatively higher heat energy. Then the third one is a specific heat capacity. So this is some physics term, but I will explain it for you. This is the amount of heat required. It is the amount of heat required to raise unit temperature of a unit mass of a body. Let's say if you have 1 gram of water, you require some heat energy to raise the temperature of 1 gram of water by 1 degree C. So the amount of energy which will be required here is known as a specific heat capacity. अभी आपको बता देता हूँ, in sense of water has probably highest of the heat, a specific heat capacity in among all these geological features. Okay. रॉक से डिफरेंट काइंड ऑफ जियोमॉर्फिक फीचर से भी ज्यादा स्पेसिफिक हीट कैपेसिटी वाटर का होता है. ओके, सो ये हम लोग यूज करेंगे लेटर इन द क्लास. सो these are the three factors on which the heat energy of a body depends. First one is your mass, second one is temperature of body, and third one is your specific heat capacity. So you know that even a body, we will not say that heat energy and temperature are exactly the same. We will see this by one more example. So let's say you have a mug of boiling water. Okay, so this is your mug. So its average temperature is, if it is a boiling water, it is near 100 degrees C, and its mass is 250 gram. You can also write 250 ml or 250 gram in this case. Now I have a tub of water. This tub is also warm but not boiling. It has been boiling earlier but now not boiling. Now let's say its temperature is 75 degrees C, but its capacity is 25 liter. Okay, we have 25 liter of water in this tub and 250 gram of water in this mug, or at place of 25 liter I can also write 25 kg in this case, because you know density of water is near 1, so I can convert this in between these two. So the thing is that if someone asks you if it is at 75 degrees C and if it is at 100 degrees C, so which one of them is hotter? Easy for you, it is the water in this mug, it is hotter. But it is the definition of temperature. It tells us about that how much body is hotter or colder, but it does not directly assimilate about the presence of heat energy. Okay, so in this case, you know it is hotter because it is of higher temperature. In this case, it is colder, relatively colder in comparison to this one. But does it means that this one has a higher heat energy? No, because I told you in this last slide, along with the temperature of body, it is also mass of the body which determines the total heat of the that substance. Okay. Meanwhile, a specific heat capacity, तो वो तो दोनों के केस में सिमिलर है क्योंकि दोनों वाटर ही है, तो थर्ड को तो हटा देते हैं. But you know, it is much more massive in comparison to this one, and even temperature difference is of 25 degrees C, but its mass is so much more that it overcomes the difference of this temperature. So in terms of temperature, it is of higher temperature, but in terms of heat energy, it is of higher heat energy by virtue of mass. Okay. So even a body having lower temperature, if it is much more massive, it may have a higher heat energy. अब आपको दोनों का difference यहाँ पे थोड़ा clear हुआ होगा. Now we will use certain examples that where even if you are supplying or removing the heat, it might not lead to change in temperature. Okay, now we are moving towards the latent heat. So when I say latent heat, what does I mean by saying so? It is the simple word meaning of this one latent heat is, it is hidden heat. Why I say hidden heat? Because even in a system you add heat, if you increase the heat input, it may not result in any temperature change. It is an irony. Doesn't it feel like a contradiction? Like आप किसी body को if you provide more and more heat, you notice temperature rise करता है. But I am saying that here in this case, even if you are providing heat, there is no change in temperature. We will see it, how it is possible. So this latent heat is a hidden heat, which is the amount of heat energy which is either absorbed or either released when there is a phase transformation. So this is the key. Phase transformation means when I am saying solid to liquid, liquid to gas, or gas to liquid, or liquid to solid. So when there will be phase transformation, even if you provide a heat, it will be either absorbed or released without making any change in the prevailing temperature. We will see it through the graphs that how latent heat works. Okay, so I say you, we'll go to the next slide. So let's make a graph like this. On this axis, we will say we have temperature, that is in degree C, and we have heat input. It is in Kelvin, I said joules. Okay, so here either you can write degree C or you can write Kelvin. For you, whatever is convenient, you can use. Now let's say I have a ice, and for me, I take a temperature minus 15 degrees C. So let's say I have an ice which is having minus 15 degrees C temperature. So now something I plan to do, I started to increase the heat energy in that case. So what will happen at first? It is temperature, it is your heat. So heat is the origin. Here I have a starting from minus 15 degrees C. Let's say here it is 0 degrees C. Okay. So what happens at first? At first, if you start to add the heat, there will be also increase in temperature. From minus 15, it will approach toward 0. Means from minus 15 to 0, there is increase in temperature. Okay. Once it reaches 0, now something miraculous is happening. There is now no change in temperature even if you are adding the heat energy. So the temperature is getting constant or stagnant here. So where does that heat go? It was the heat which was utilized for phase transformation, because you know 0 degrees C is also the melting point of pure ice or pure water. अगर pure water बोलेंगे तो it is the solidifying point of pure water, or you can write also it is the melting point of pure ice. So what happens at 0 degrees C? Let's say the origin was A. Okay, I will change the color for you. And then it is B and this is C. So what happened from A to B? There was only ice. So since there was no phase transformation involved, so it means there was no, you can say it was having a linear relationship between temperature and heat. Once it reaches 0 degrees C, now two phase will exist. One will be your solid ice and then second one will be your water. Now what happens, even if you are adding a heat, it is showing a stagnancy. So unless each and every unit of that ice has been melted, there will be no change in temperature. Let's say I took this ice of 50 gram. Even if I have melted 25 gram, still the temperature will at 0. Once all of this 50 gram has been melted, then only the temperature will again show any increase, or it will show the linear relationship there. Okay. Once it go from B to C, now at C what happens? All of the ice has been melted. Now what will happen? Again, once the temperature will start to increase from here. So from C to D, the temperature is started to increase. But in this case, at first we were only with ice. At B to C, we were ice and water. Then at C to D, we have only water. So since there is no phase transformation involved, again temperature will show a linear relationship with the heat input. But जब आप यहाँ पे आते हो, this is let's say 100 degrees C. We are considering pure water, so keep this in mind. That's why the boiling point is 100 degrees C here. Okay. Again, you will notice the temperature after 100 degrees C is not getting increased, and from D to E, it will keep a stagnant or constant at 100 degrees C. Even if you are increasing the heat, it will not show the linear relationship, rather it will show a stagnancy of temperature. Now what is happening, at one side your water is giving way to the vapor. So again there is phase transformation, so there is no you can say temperature rise or temperature change here. So unless all the 50 gram of water has been converted into vapor, there will be no change in temperature, because the the heat input has been used to change the phase here. So from D to E, again here there will be no change in temperature. Once the whole of this water has been vaporized, again the temperature will start to increase, okay, like this from E to F. So from D to E, again there were two phases. Now from E to F, you have only gas, or let's say we have water vapor. 1 minute. We have only water. एक second. We have here only water vapor. So what we learned from here, once it was ice having minus 15 degrees Celsius, from here, since there was only one phase, you started to increase the heat input. So temperature was showing this linear relationship with heat. But once it approaches 0 degrees C, where two phases of water exist, one is ice, one is water, then there will be no change in temperature, even if you are increasing the heat input. Once whole of the ice has been melted, again there will be only one phase, that is in form of water. Again the temperature will start to show the rise, and also it will show the linear relationship with heat. But once it reaches 100 degrees C, what will happen here? Then we have two of the phases. One is your water and then vapor. Again it will show a stagnancy, so there is no linear relationship. Now once the whole of water has been vaporized, again it will show an increase in temperature with the heat input. Okay, तो आप यहाँ पे देखो. So here, if you do not observe any change in thermometer, so what you say? These are the latent heat. These are the hidden heat. Okay, so this heat, if you are increasing the temperature in this way, we call it latent heat of fusion, and we call it latent heat of vaporization. So this is latent heat of fusion, this is latent heat of vaporization. So since you are increasing the temperature in this process, so it means the heat is getting absorbed. Okay, in both the case, since you are increasing the temperature, the heat is getting absorbed in this system. So that's why they have a net cooling event. Okay, or it means that it has a net cooling effect. So that's why if you put some hand sanitizer, alcohol-based hand sanitizer, you will feel some kind of coolness. Why it is so? It absorbs the heat on the surface of your hand and it vaporizes. So that's why it is absorbing the heat. So naturally, if ये आपसे heat absorb कर रहा है, तो आपको cooling sensation feel होगा. Even in nature, you will see, like during the sunny day, if there is sweating and if it is getting absorbed easily, so you will feel a cooling sensation. So that is one of the processes, one of the significance of these latent heat of vaporization, that both latent heat of vaporization and latent heat of fusion has a cooling sensation. Okay. So now in this process, we were increasing the heat input. Now we will do one thing. Now we will decrease the heat input or remove the heat from the system. इसका opposite अब करके देखते हैं. Okay. Again, I will make this graph like this. Okay. So now what happening? You start from F. Okay. So now what happens? At first, if you remove the temperature, heat, not temperature. You can't remove temperature. You can only remove the heat. So at first, it will show linear relationship unless it reaches 100 degrees C. From F to E, there will be decrease. This is again heat input, and this is your temperature, change in temperature in Celsius or Kelvin. So at first, since there is only gas or vapor form, since there is no phase transformation involved, if you remove the heat from the system, it will also show a decrease in temperature. But once it reaches 100 degrees C, where both, if you are removing the heat from the system, both vapor and liquid water can exist, and we call this process as condensation. We will see it later. So from E to D, again the temperature will remain constant at 100 degrees C unless each and every molecule of vapor has not been transformed into water. When all the molecules of vapor has been transformed into water, now you are remaining with only one phase, that is your liquid phase, or you can say form. From here, it will again start to show a linear relationship. If there is decrease in heat, there will be also decrease in temperature. But once it reaches 0 degrees C, what will happen? Again, even if you are removing the heat, it will not show any change in temperature. Why so? Because at 0 degrees C, there is water is now started to getting converted into ice. So again, there is a phase transformation is taking place. So in this case, there is release of heat, like in first case, even there was release of heat. Then there what will happen? The heat will be released out of system without changing the temperature, and this heat, unless the each and every drop of water has not been converted into ice, then there will be no change in temperature and thermometer will show 0 degrees. Once every drop of water has been converted into ice, it will now again start to show the linear relationship. From here again it will go to minus 15 degrees C. मतलब और भी आप कम कर सकते हो, but for the purpose we have took it only told 15 degrees C. So इसमें क्या देखा? After all, each and every drop of water has been converted into ice, you are only left with ice. So in both the places, you can notice similar trends. If you are increasing the temperature, if there is only one phase available, then temperature will show linear relationship with the heat. But once if there are two phases present, let in this case water and here ice and water, so what is happening? There is no change in temperature. Means if there is phase transformation, it will show a constant temperature. Again, you can see it here in the case of transformation of water into vapor. So here we call it latent heat of, if you are increasing the heat, first we call it latent heat of fusion, latent heat of vaporization, and I told you they have a cooling effect because they absorb the heat, okay, without changing the temperature. So that's why they have a cooling effect. In this case, since here we call it latent heat of condensation, because the water is gas is transforming into water, and you know, if something is changing from gaseous to liquid form, we call it condensation. And this one we call it latent heat of solidification, if it is transforming from water to ice. In both these cases, there is release of energy. In this case, if there is transformation from vapor to water, there will be release of latent heat of condensation, and if ice is transforming, water is transforming into ice, there will be release of latent heat of solidification. Now this puts us into a query. Are not this latent heat of condensation and latent heat of vaporization same? The second question, are not this latent heat of fusion and latent heat of solidification same? Maybe, maybe not. We will see. So when I say latent heat of condensation, in magnitude terms, they are similar to latent heat of vaporization. Same thing goes for latent heat of fusion. Just a minute. Yeah. latent heat of fusion in magnitude terms, it is equal to latent heat of solidification. As you can see it here, compare this graph. This is your, if you are increasing the temperature, it is latent heat of fusion, it is latent heat of vaporization. In this case, since you are decreasing the temperature here, okay, what it is latent heat of condensation and it is latent heat of solidification. So in terms of magnitude, they are equal, no doubt, but they have a opposite effect. In this case, condensation, you are releasing a heat. In this case, you are absorbing a heat in vaporization. So what will happen? Condensation has a net warming effect on the atmosphere. Vaporization has a net cooling effect on the atmosphere. Okay. And since for the precipitation and cyclone, we will consider mostly on these two, that why they are important. Okay. ये थोड़ा सा climate change में important है, latent heat of fusion and solidification. But okay, sorry, it is latent heat of solidification. So for the purpose of this weather phenomena and all, we will keep ourselves dedicated to this portion. So now you know what is the application of this. Okay. So when I say application, it is related to the atmospheric example. So when I say there is formation of water vapor, if you, let's say water vapor को जब आप liquid में बदलते हो, so what happens? There is condensation. So what will happen? There will be release of latent heat of condensation. So that's why if there is cloud formation, means there will be more heat produced due to the latent heat of condensation. And what does those heat do? It creates the towering cloud. Okay. Reason इसका बताता हूँ. You might be wondering that how these towering clouds form. So first thing first, if I ask you, चलिए इससे अलग थोड़ा सा पूछता हूँ. Which one of them is heavier? Is it the drier air or is it the wet air? Many of you will see it is wet air. No, it is drier air which is heavier. For drier air, it is N2 plus O2. अगर इसका total आप देखो तो 14 plus 16, it is nearly 30 of molecular weight. For drier air, sorry, it is drier air. For wet air, we have H2O replacing some of the portion. So in this case, it has only 18 of molecular weight. So that's why from here you can always say that drier air is heavier than wet air. Okay, so these are the things. So when I say the more moisture it get, the more it will be lighter. Okay, अब देखो इसमें दो चीजें. एक तो आपको पता है the wet air is lighter than drier air, first thing. And the thing is that wet air have more moisture. And what does this moisture do? Upon getting upwards, they transform into liquid. Okay. And more transformation means more release of the latent heat of condensation. And with it has a net warming effect. And you know, warming anything provides it's the additional buoyancy. So as you provide more heat, means that the cloud will rise upwards and it will form a tower kind of situation. So this is the source of all the thunderstorm as well as cyclone, where you can see the cumulonimbus clouds and all. Okay. So this is the application of physics in climatology, where I deal with all these scientific phenomena in the you can say using these physical features and all those things. Because you know, अगर सिर्फ इसको simple way में आप समझोगे तो it is problematic. But climatology is completely science in itself. Although it is part of geography, but for me, you have to deal it with proper application of science. So hope so you liked this class, and we will later see that how it is applicable in the cyclone formation, thunderstorm formation, and so on. Thank you.